with its evaluation. It's a fancy way of saying every time we get an expression, we have to figure out again what it is, even if we've looked at it 3 or 4 or 5 times before. So if we're calling fact of 10, every time we call that factorial procedure again, we call that lambda expression, we have to figure out again what's happening inside the body of that lambda. That's wasteful. So basically, so we can transform MC eval to perform an analysis only once. Okay. And this here, performing an analysis only once, is what's integral to compilation. When we compile a program, we're going to analyze it only once, and then we're going to use our compiled code. Right? If you have compiled code, basically what we've been doing in Scheme is we've been using interpreted code. We type code in, and Scheme figures out, in the process of running it, what the code is. If you compile code, you write your code, you compile it. That compile step just analyzes the syntax, figures out what's going on in it, creates a blob that can be run, creates an image that can be run. So this analysis is part of the compilation process. Analysis separates out the structure of the expression, the computation, from its execution. Which is what compilation basically does. Yes?
Is this why I've noticed sometimes when I preprint something that I typed in, a procedure that I entered or defined, it preprints differently than I defined it? Is that what's going on? It's analyzing it partially?
What's different in terms of just the indentation, or?
Well, for example, sometimes I've noticed, I think with a con, it'll change it and it'll have an if in it, and I never wrote it with an if.
Right, that might be what's going on there. There's some internal change there. Although I would think that pretty print was true to your definition. So it must be doing some.
It also desugars defines.
Right.
And I think, I'm not sure about that.
Right. So when we type it in, the desugaring's done. So cond would desugar into an if, just like it does in the metacircular evaluator. If you look at it, that does it there. So the desugaring must be done for the pretty printing. But not any sort of analysis, just a desugaring. There's no analysis there.
So why is it obvious that it's more efficient to compile it first? I don't see it.
It's not obvious, and it's not necessary. Actually, in some cases, it'll actually be less efficient to analyze or to compile. If we have an if statement in which the predicate and the consequent are very large statements, we have to go through, we have to analyze them. We have to analyze the predicate, analyze the consequent, and the alternative. If we only use that if statement once, we've analyzed both the consequent and the alternative when we're only using one of them. Where the win is going to be is if we have a lot of recursive code, we have statements that we're using over and over again. If we've written a procedure, defined a procedure that uses a lambda, and we call it procedure a lot of times, we've already analyzed the body of that lambda. So it's for pieces of code that we're using a lot of times. If we're writing a simple if statement, if ABC, and we only executed that once, then analysis isn't really going to buy us that much. What you'll see on problem set 10 is that you'll have a chance to time the two things, to compare them. So you can try different statements and try an if, ABC, and see which one takes longer. And then you can try defining factorial and see which one takes longer. So it's winning when we're doing things over and over and over again. So the result of analyzing an expression is a procedure that takes an environment. So we're separating out the analysis from the application. The analysis can be done without knowing what the environment is, because the code's going to act the same way. Right? If we write a lambda expression, it's going to take the same parameters and bind it to the same names, and the body is going to do the same thing. It's just going to depend on the value we pass in to bind it. So we can analyze our expression in the absence of that information, in the absence of the environment, and then apply it to the environment. So our new eval is going to look like this. Eval is still going to take in an expression and an environment. The difference is that we are going to first analyze the expression and then apply it to the environment. Okay. This is where we need to analyze the expression. So you guys have the code to analyze the expression. And on page 1, we have the analyze procedure. So analyze should, in some sense, look a lot like MC eval to you guys, right? Because analyze is where we need to go through and check out what type of expression we have. Self-evaluating, quoted, variable. Because we've taken that part out of eval now. Eval used to have that big con statement for us. We're moving that out into the analyze procedure now. So if we've got something that's self-evaluating, so a number evaluates to itself, what we're going to return from analysis is a procedure that takes an environment. Okay. What does a number evaluate to, or a symbol? Itself. So what would this lambda expression that we want to return look like? Okay, I hear lambda XX. Is that exactly right? No, we want to take in the environment. The procedure needs to take an environment. All of the procedures that we analyze, that we return from analysis, are going to take the environment in. And then we're going to return the expression. Okay, so this is actually skipping an abstraction layer that you guys have on the code in front of you. So there's actually a code in a call to analyze self-evaluating.
That environment that it takes in has no effect on the results, essentially.
In this case, it has no effect on the results. However, we need to build it all up.
You don't want it to in this case.
Huh?
You don't want it to have an effect in this case.
We don't want it to, but it doesn't. Right. Right. It doesn't. We don't want it to. But we need to have a consistent interface. Right? Because up here, we're going to take the analyzed expression and pass an environment to it. So if we had just tried to evaluate 1, and this didn't return a lambda that took the environment, it would break. Right, so we need to have that consistent interface so that this will work up here. Okay, so if something is quoted, we call analyze quoted. What should analyze quoted do? If we have an expression, ADU quote, whatever, Holly, we could have just as easily had ADU quote ABC, something. If we've got a quoted expression, what do we want to do? Well, if it's quoted, do we need to do any analysis on it? No. That's exactly what quoted means, that we don't look at it, right? So analyze quoted will take in an expression, and then what it's going to do is it's going to have a let with the Q val being the text of the quotation of the expression. You do not have in front of you the code that has text of quotation in it. Analyze can inherit all the syntax that we had from the metacircular evaluator. So all the expressions that we had there for pulling out the syntax of a language is inherited. We can use the same one that we used from the metacircular evaluator. So the text of the quotation is going to be the what? If we had a list structure look like this. Catter? Catter maybe? Catter? Please? Catter? Catter. Good. Okay. And then we're going to return lambda of expression with the Q val. Here's a question for you. Why did I have that let? Why do I have a let here instead of just simply saying lambda expression, text of quotation, lambda environment, text of quotation expression there?
Try to evaluate the Q val, or in the lambda it would try to evaluate it.
It's not that it's going to try to evaluate, it's that it's going to have to. Every single time we call this, oh, did I write lambda expression? Excuse me. Lambda environment. If we had instead text of quotation expression inside that procedure body, this is the procedure that's returned as the result of analyzing, which means that any time we use this expression, we'd have to do the catter again and again and again. Right, so that basically removes the whole point of doing analysis if all we've really done here is just wrapped a procedure that takes an environment around it. We haven't done any analysis. We've just left that expression there. We have to pull it out every time. Okay, so that's not a good idea. This is the right way to do it. So the next one is a variable. How would we write? I'd like to recommend that you guys don't look at the sheet. Just think about how we would write it, and then look to confirm if you'd like. It's a good exercise to think about how we would analyze all of these things. So how would we write analyze variable? Right, so here we actually have to do this. A variable in the absence of an environment is just a variable. So what we're going to do is we're going to have a lambda that takes in an environment, and then it's going to look up that value in the environment. Okay, in the absence of an environment, we can't do anything to the variable. That's it. We've grounded out there. So the next one on the list is we're checking to see if we have an assignment, which corresponds to what statement? What's an assignment?
Define.
That's the definition. Set bank. Okay. So we're going to define analyze assignment of an expression. Okay. So what parts does a set bang have? A set bang has a variable, and it has some value. So what's likely that I'm going to want to do here? What can I do before the lambda? What's the stuff that I can do in the absence of an environment? I can analyze this. Well, I should also analyze this. Even though it's likely that it's just a variable name, we still need to analyze it. So I'm going to have a let, and I'm going to let my variable actually be the assignment variable. Sorry, lied. Don't need to analyze it. Because we're going to actually pass this into another procedure that's just going to take it as a variable. So our variable is going to be assignment variable, and then we're going to the variable procedure, this is where we do the analysis. There we go. You're going to analyze the assignment value of the expression. 1, 2, 3, 4. Okay. So the assignment variable is going to pick off this. Assignment value picks off this. So if we had something set bang A1, what's the result of the analysis of that? I hear 1. Is it just a 1?
The lambda that returns 1.
All right, so it's going to be a lambda env 1. But what if I had something like set bang A times A 3, 4. Let me put an operator in there. Now the analysis here is going to be more complicated, and it's going to go off and do some recursive calls to do that analysis. But we don't know when we're just getting the syntax what it is. That's why we have to make that call. We're not going to check here. It's silly to check here if it's a number because we've already got something that's going to do that for us in the analyze evaluator. There's no reason to duplicate that code.
I think I've lost sight of how it makes it more efficient if the analyzer runs through and checks all of this anyway. What are we gaining then by?
What we're gaining is if we're using the code over and over again. So that we've analyzed the expression, we could say that that's some recursive procedure, maybe fact. And then we apply it to the environment. And on the recursive calls, we're going to use the analyzed expression. So what's buying for us is we're not going through the cond in the MC eval every single time that we need to make that recursive call because we've already analyzed it once. Okay, and like I said at the beginning, it could also be a slight lose for us if we had an if statement that we only executed once. It's not always going to be better. But for the most part, because of the way we write scheme code, because we do write recursive code, it's probably going to be a win for us.
So in the future, we just make calls to analyze. We don't call eval.
No, we'd still need to call eval. So we could actually, you could think of this as replacing MC eval if you wanted to have the metacircular evaluator have analysis in it. So the driver loop would still call MC eval because if we only call analyze on the expression, we lose this. We lose this application to the environment because we still need to check. We still need to evaluate within a certain environment frame.
But analyze still has the con.
Analyze actually is the cond now, right? So the whole checking of the syntax is at analyze now rather than being an MC eval. We've brought it down into analyze. The analyze is going to be run once when we call MC eval, or we could call this analyze eval if you'd prefer to have it be a separate name. If we call analyze, we'll do this analysis once, and then we'll apply it to the environment. And if there are any recursive calls, we'll be using the analyze procedures.
We're going to store these
Hmm?
someplace. We're going to put them in a table someplace.
It depends. If we're just using it and we haven't defined it to anything, we'll use the lambda, we'll analyze it, we'll use it right then, and then it goes away.
Then the next time it's called, it still has to recalculate it. So it doesn't.
It depends. Okay. If we've defined, let's say that we define fact n if equals n0, return 1, otherwise times n fact minus n1.
So the ADU define ADU with.
Yes, sorry. Everything is ADU. ADU everywhere. And we could ADU the variables too, but let's just save that step for now. Okay. So now we're doing an ADU definition, which means that the result of analyze the lambda expression that this desugars to, that's the ADU define to be ADU fact to the ADU lambda. Yeah, okay. Yeah, I know. I should be writing all this out, huh? fact define the ADU lambda of n, ADU if, ADU equals n0, 1, ADU times, and ADU fact, and this is ADU minus, by the way, ADU minus, and 1. Some number of parentheses. So when we call the analyze evaluator on this, what's going to happen is we're going to analyze the entire expression. And what's basically going to end up happening is that we're going to bind ADU fact, this variable name, to the result of analyzing that procedure. So from then on, every time that we call ADU fact, we're using the analyze procedure. Okay. If we were to just use a lambda, if we were just to say something like ADU lambda x ADU times xx applied to 3 here, then we do the analysis, we apply it, and it's gone. Okay. So in that case, it would be gone. But in the case where we were defining it to be something here, then every time we call fact, we get to call the analyzed expression over and over and over again. So that's one place that we're winning.
So this, did I understand correctly? This analyze doesn't really work for us if we did not name the procedure?
It works for us. It's going to work the same. But the thing is,
It's going to lose the efficiency.
but it's going to lose the efficiency, right? Because if we do an analysis and we don't bind it to anything, when we do that analysis, most likely it's not buying us very much if we're only doing something once.
Well, I'm curious, when we run even an unnamed lambda, it still, I think, gives us a proc, a procedure number or something, right?
Right. Well, it still has to be an internal representation of the procedure, but it's not analyzing the syntax of it. Right. So Scheme still needs to say, I've got a lambda, I make a procedure internally, but it may or may not be analyzing the body of that. In this evaluator, we would be analyzing the body of the lambda before we applied it to 3. Okay. In the metacircular evaluator, we would not. However, in this case, the analyze evaluator and the metacircular evaluator are basically the same. Because in this case, we go through, we figure out in the analyze evaluator, what is this lambda expression? Now I'm going to apply it to 3. In the metacircular evaluator, I would do the same thing. What is this? Now I'm going to apply it. Okay, so in this case, you can think of it as being the same as MC eval. So this is A eval being the same as MC eval. Now, if we had this case here, ADU if ADU greater than AB, and I'm going to, if A is greater than B, then I'm going to ADU if times A times A. Otherwise, I'll do ADU times B times B. Now, we haven't looked at analyze if yet, but let me just tell you what we're going to do for analyze if is that we're going to analyze the predicate, we're going to analyze the consequence, and we are also going to analyze the alternative. So if this if statement is executed only once at the prompt, we're actually doing extra analysis that we wouldn't have done in the metacircular evaluator. Because we're going to look at both the predicate, or rather the consequence, and the alternative. So both will be analyzed.
Is this going to throw a wrench into our special form? The fact that we could theoretically have an invalid statement in either the consequence or the
We couldn't have invalid syntax, but if we had something that was going to spin off an infinite loop, is that going to cause a problem for us? Well, what's analyze doing? Is it doing any sort of application? It's doing any sort of apply that's going to cause us to get into an infinite loop?
Don't think so.
No. Okay, that was I have no idea, but let me go with 1. I have a 50-50 chance here. Okay.
Giving us clues the way you present the question.
Trying to lead you down that garden path. Okay, so analyze does no application. Right, you can think of it as simplifying it.
It will do things like turn the cons into ifs. That whole sequence will only
Right, but that's not an application.
Right, no, but I'm saying, but in terms
Right,
of
it'll desugar it, so it's going to simplify it for us. It's basically, you can think of it as it's going to be parsed once. So we're going to parse our string that we're passing into the analyze evaluator once. And we're going to create a procedure the underlying scheme can then just use. As opposed to if we had defined fact in metacircular instead of in the analyze evaluator, every single time on the recursive call, the metacircular evaluator has to figure out once again, what is this? Has to figure out the body of the lambda again. So it's reevaluating it over and over and over again. So the analysis is pulling that out for us. Yes, sir?
Percentage-wise, what's the percentage of processes that this eliminates?
John? He's not paying attention. The question was, do we have any sort of feeling for what sort of percentage of useless stuff this eliminates? Of additional work. I'm sure there's been an analysis. I don't know.
9.8.
Most of the time, we're not going to be writing stuff like this, right? I mean, most of the time, we're not going to be writing code like that. We're actually going to be wrapping a define around it and doing something with it. We don't normally, I mean, how often have you guys in the last, I was going to say a couple of months, but few weeks, actually gone and just typed in an if statement at the prompt and evaluated it? Last night? Was it a metacircular one, though? Okay, so see, you were just checking out ADU if, but an actual if at a scheme prompt. Do you guys do this much? Well, yeah, once or twice, right? You might check out, make sure your logic is right before you go in and put it in somewhere, or you might have tried to figure out what if was doing, or you might have redefined new if or something. We don't do this normally. What we're normally doing is we're writing procedures that call themselves, that call other procedures that we can call, right? We're usually writing code that we can use, one would hope.
More generally, is there anything within Scheme which measures, I don't know how you'd phrase it, computational, the amount of computation you demand the processor to do, either in terms of clock cycles or computation?
We have actually, this will come out in exercise 10, there is a procedure called time. And if we take time is passed a lambda of no arguments. So we pass a procedure of no arguments. Actually, brackets. So what we can do is we can say something like time, lambda, no arguments, fact, 10. And this will return the amount of time that the computer took. Okay, so this is what you're going to get to play around with on assignment 10. So what we can do is we can check our timing with ADU fact 10 when we're running in the metacircular evaluator. Then we can check the timing of it when we're running the analyze evaluator. We can compare it that way. So you guys can go and type in an if statement and try it out and see which one takes longer. You're not going to see much of a difference with time. In fact, you might not even see any difference with time because it's not even going to be long enough in either one to give you guys a differentiation with timing. I don't think time is that fine. I was playing with it, and it seemed to be returning 0 on very simple things. So it's not going to give us much on this sort of case. It should be counting only the time that it gets to process it, hopefully. It should be counting its clock cycles, not the clock cycles of the computer.
So just to clarify, in MC eval, it would have just bound fact to a procedure. It wouldn't have cared what the procedure is.
Right, so what MC eval does is it pulls out the parameters of the procedure, and it just says, this is the body. Doesn't even look at it. So in fact, we're not looking at anything about the syntax here until we go to call it. So now fact is bound to a procedure object that only knows it's going to take in an n and do something with it. but it hasn't looked anything about what it's going to do with it. So every time that we call fact recursively, we need to figure out what that body does. So every time we're making that new call, we're figuring out what the body's doing.
Whereas with this one, it's
With this one, we've already figured it out. Right, we've gone through, we've basically analyzed the syntax, and we've made it into a procedure object in the underlying scheme that we can just pass an environment to, and it's going to run. So we're not going to have to make all these recursive calls to the con that's on the lower layer of the board here that you can maybe not see. But if you look at your analyze, we're basically not going to be going through that con statement over and over again like we were in MC eval.
Do we just punt to the scheme evaluator, and that's why in this case it's, I mean, because we still have a procedure to evaluate that we're returning from here.
Scheme has to do evaluation, sure.
So I guess I get kind of caught in a circular loop of like, I can understand to a point why what we're receiving is more efficient than going through the con statement every time. But then what that procedure we get back itself needs to be
Evaluated by underlying scheme.
okay.
But you can think of it as we're not parsing it over and over again.
Okay.
Scheme is just going to evaluate it and apply it down at its level,
Okay.
which it would have to do in either case. Right?
So-
In either case, with the metacircular evaluator or the analyze evaluator, underlying scheme is going to have to do the eval apply cycle. And that's what scheme's doing. But we can think of this as what we're doing. Are we being smart with what we're sending to scheme? So we're basically writing a parser. And is our parser going to have to reparse every time?
Okay.
Or can our parser use some stuff that we've already done before? So analyzer is using stuff that we've already done before, and MC eval is not. Other questions?
So is this like a compiler, or is
You can think of this as one step towards compilation. Huh? Yeah, I mean, so a compiler is going to have to analyze the syntax for us. But at the heart of it, we're still an interpreter. We're not actually creating compiled code that we're running over and over again. Yeah,
It's not independent.
it's not independent, but it's a step towards it. I mean, it's
But I mean, the code we're generating here isn't independent of the interpreter, so.
right, right. We haven't been able to decouple yet.
I think maybe I'm just having some substitution model forgetfulness here, but looking at the big con statement that's in analyze now,
Mm-hmm.
it seems like it would be very clear to me that this was more efficient if I could look through this and like the first thing I did go through the consequent of each of the con statements and expand that out into what we have down below, right? Which is where you do all the desugaring and all the simplification happens. Like for analyze quoted, we find analyze quoted is this thing that actually does the work.
Mm-hmm.
So if I can think of just sticking that up in the place of the consequent after quoted, right?
It's the same thing, right? You're just substituting it in. Remember, all of this stuff on this page is scheme level. All of this is running at scheme level for us. The fact that we're calling a procedure that's going to analyze it isn't. I mean, it's a procedure that's been defined that's going to have a lambda. It's the same thing. We could substitute it. We could write it up here. It would make the code harder to read. Because while analyze quoted or analyze self-evaluating is a relatively short procedure, as we get on to the analyze if, it'd be much longer, and this code would just be very messy to read, which is the reason for breaking it out.
Does that expression, analyze quoted exp, does that get evaluated the first time it finds a quoted? That's what I'm trying to remember. Does that get, the first time that gets evaluated is when the first time the predicate is true. Is that right, or does that?
Anytime the predicate is true. If we have something that's passed in that's quoted here, we're going to analyze it. But if we have something that's quoted with inside of a procedure object, it'll be analyzed that once, and then we built up a whole procedure object around it, and now when we go to use it, we don't need to keep checking for quote. So let's say we had some recursive procedure. Which is going to take in some variables, A and B. And let's see, what can my example do? If A is equal to 0, then I'm just going to return.
These are all ADU again.
Yeah, ADU. 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 All right, so let's make this a cond, actually, because I'm going to play with more stuff. Cond. Okay, so if we've got ADU equals 0, then I'm going to, let's see, I'm going to return a list of, quote, I don't even know, C, quote, D. This is one of those examples that's just not going to do anything. I'm just trying to put quote inside of a recursive procedure. Yes? Do you have a better example? Because that would be good.
I don't have a better example, but what might help is to go through.
Following something through?
Follow something through and follow it through both ways. So we can really see the difference.
Okay. This sounds like a case for colored chalk. No! I'm just not adept with the colored chalk, as John is. He must have extra hands. I just can't do the colored chalk. I need colored chalk boy up here. You can be my colored chalk boy. Can I? I'm going to leave now.
I think we really want to cut that off the tape. You don't want to be running for president and have that come back on.
You know, it's all of you people with the dirty minds, not me. Oh, God.
We're going in the flags.
How fast does a swallow fly?
I'm going home. I'm drinking more caffeine. Excuse me. More caffeine. Should I give you a little cut for when we want to come back in?
We need a clapper. So
People are mean. Mean. Because somebody told me that yellow and white was not working well.
green.
Green and white?
They're all pretty good.
Orange is really nice.
Orange? There's not much orange left. Okay, we're still not back on, by the way. That's lovely. All right, let's follow something through. Teek-a-teek-a-teek. And now we're back. Hello. This is a commercial break. Oh, my God. Mean, evil people. All right, let's call eval, and let our expression be edu define, edu fact, and I'm not going to tag the variables. And let's see, let's write this across. Edu if, edu equal, and 0, 1, else, edu times. Oh gosh, it's supposed to be orange, isn't it? Okay.
You just do this one to the other one.
I'm supposed to be an orange. Okay. Whack. No. We can edit that too. All right, let's try again. So now we're going to. Oh, some lectures should not be taped. ADU define. ADU fact of something. N. To be ADU if ADU equal N 0 1 of something or other of ADU times. I'm too high up to actually read what I'm writing. I actually cannot read. Oh, I thought it was John coming over. I'm like, oh no, he is coming over. I'm failing with the colored chalk. Oh my God. ADU fact. ADU minus something. N. 1, 1, 2. Closing the times, closing the if, closing the define. In some environment, which is going to be the global environment. Yay! And there was much rejoicing. Okay, so we're going to evaluate this. So eval at the top of page 1 says that's going to be analyze the expression with relation to, and then apply it to the environment. So this is going to be analyze this here blob string actually, but you know, we'll say blob for now in relation to the global environment. Cool. Okay. So now we're calling analyze on ADU define, ADU fact, blah, 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 blah. So we go to analyze and we look at the cons. Is this self-evaluating? Please! Come on! Thank you. Thank you, Sharon. It's not quoted, not a variable, not an assignment, but it is a definition. Woo! So we are going to call, right now we're doing this. That's what's going to spin off to this. We're sort of forgetting its application to the global environment. So we're going to analyze definition on blob. Blob. I like blob, but eventually we'll actually need to go into the middle of it. Analyze definition is about 2/3 down the way. Do you have a handout? You have a handout? Let's get Alex a handout.
Our viewing public will have a handout.
The viewing public needs to have a handout. But they will not understand the in-jokes, unfortunately, for the viewing public. This is on page 1 near the bottom, analyze definition. Okay. So we come into analyze definition, and we have a let. It's going to be a little bit weird to do without drawing out a full environment model. I hear we'll manage. Oh, please tell us we'll manage without the environment diagram. All right, so we're going to...
We need to step through the details of analyzing every last bit of that script as much as we need to see the difference between analyze and MC-eval. Correct me if I'm wrong.
I agree with that.
Okay, but I cannot, I'm not a computer. I won't be able to pop up the analyze lambda for you right now.
Yeah, but
So in some sense, we kind of need to go through it, because I just can't do it off the top of my head.
yeah, like I could deal with a fudged lambda.
Okay.
Will the analyze lambda have all kinds of lambdas embedded in it?
Yes. Can we do a couple of layers here? We don't have to go down the bottom.
That's a good idea.
Okay. So we're going to let the variable be the definition variable and the procedure be the definition value. Okay. So the definition variable here is going to be this. Okay. Remember that definition in MC-eval, this is the same syntax that we're using in both. Do you guys recall that definition is going to check to see if we have a sugared lambda? Vaguely? Maybe? Okay. So this is going to be the variable name, and it's going to desugar this into an ADU lambda, which would be orange, wouldn't it? It's going to be an orange. Lambda of n, blah, 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 blah. Okay, so this here out to, I think here, is going to be the vproc.
So those were defined in our other sheets.
Those are on the syntax sheets.
Definition variable.
Yes. Yeah, you have all that stuff. I didn't want to make another 12-page handout when you guys already had the code. It seemed like we were killing a few too many trees. Okay, so analyze definition is going to let this be the var and that be the vproc. Well, what we do is there's a let that we return the definition variable. Okay, so that's just going to be ADU fact. But we need to analyze what's being defined. So we need to now analyze the definition value of the expression, which is, well, this here. That's actually not vproc. Vproc will be this. So So we're going to take this thing here, and that's going to be this thing here. So we're going to analyze ADU lambda and ADU if blah, 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 blah. Check? Everybody following, sort of? Okay, so this is the lambda. Okay, so if we go into analyze again now, we come down to the lambda, and we call analyze lambda. On this, which is this. So we're going to analyze the lambda. If we go to analyze lambda, which is at the top of page 2, everybody flip your page. We're going to let the variables be the lambda parameters, which if I have more colors, don't I? Whoa, look at this. It's very exciting. Here, at this level, these are the vars. And the lambda body, which is this, here, is going to be, that's the lambda body. And we are going to analyze sequence on that body. Check? Orange, green, white, button. Okay, so we're going to analyze the sequence on the body. Okay. So we're going to analyze sequence on the body. So basically, analyze sequence is going to go through, and actually we only have how many expressions in our body?
One.
One?
Just the if.
Just if. So, analyze sequence, which is underneath analyze lambda. We define a couple of procedures sequentially in loop, and then we let the procs be map analyze over the expressions. Okay, so we only have how many expressions? Just one really long one, the if. So we're going to map analyze over it. So in this case, analyze sequence is only going to be analyze. So now we're analyzing the body. So now we go in and we've got the body, which is this ADU if here. We need to analyze that. So we go back to our cons, and we're going to analyze the if. So we call analyze if on this green blob. Is this helping?
Yeah.
Really?
Yeah. Will the analysis of that have if in it?
Hmm?
Will the word if just drop out of this, or will it keep coming up?
Well, if we look at analysis if, I mean, there needs to be some if there, right? So the analyze if, well, so what's going to happen is the analyze if is going to pull out the predicate, the consequent, the alternative, and analyze those three things, and then pass those to underlying scheme if. Because we need to write our ADU if in terms of the scheme if. We need to write it in terms of something. So we're basically inheriting all of underlying scheme. We're using that to help us build this level up here.
If is where we're going to actually see the difference, right?
Yeah. The question is, did we finally make it? God. All right, so analyze if. So actually, let me write the blob over again, because it's just getting too messy up there. On ADU if, ADU equal, and 0, 1, ADU fact, ADU minus, and 1. Okay, so when we come into if, there's three things that we need to do. We're going to analyze this. And when we analyze that, that's going to be the predicate of the predicate proc. This here will be analyzed. And it's going to be the consequent proc. And this here will be analyzed. And it's going to be the alternative proc.
Did you leave out a bit with the ADU times and before ADU
Oh, yeah. Yeah, no. Doo-doo-doo. I got lost in Color World. No, did not get analyzed. I just got lost in Color World. Just not as adept as, well, I just won't say that. Go there. Okay. So we're going to analyze this, and this is going to be our predicate. We're going to do a predicate procedure returned, which is basically going to be a lambda that takes an environment and is going to apply the primitive procedure because it will have evaluated down there. We'll have analyzed that to figure out that's the primitive procedure to a variable n that's going to take the environment, find its binding, and a lambda that takes in an environment 0. So it's going to all get down to basically all sorts of nested lambdas. See how that might go? Should we follow another one of these all the way down the bottom? Should we go all the way down the bottom? For the love of God, no. I'm here.
So in the end of all of this, what we have when we go into eval is a string list, basically, of a lot of text. And
what this whole thing is going to end up returning is lambda env, and then inside of this will be something like lambda env.
All the original code, you find those lambdas in the bottom, right? You'll see all the ifs and all that, all the arithmetic and all the multiplication.
No.
No.
What you're going to see in these procedure bodies is going to be scheme code. White code, scheme code. We're not going to be seeing orange or green or blue or purple code anymore. In MC eval, we are always going to be looking at orange, green, or purple code. Okay, that's the difference. Is the analyze is translating everything into white code.
But you'll see.
Not to imply that white is any better, of course, but the underlying scheme code is in white. I'm hearing I have racial profiling on code. God. I'm losing today. Yes. Somebody had a question over here. I think that's.
Where does it not do that a second time than it would have otherwise?
Okay, so basically what's going to end up happening is we're going to get this huge lambda expression, right? And then we're going to come to the point where we were doing an analyzed definition. And once we've got this huge lambda expression, we are going to modify our environment to bind ADU fact will be bound to this. So from then on in, anytime I call ADU fact, whether it be recursively or the first call, I will be using my analyzed expression. Right, this whole expanded lambda m, lambda m, lambda m, lambda m.
So what you were pointing at, saying this whole thing expands into that ADU, or into that after ADU.
This is going to be this whole, well, basically this is the variable, and remember this went to ADU lambda of n, ADU if, ADU equal, blah, blah. So, right, so we desugared the define, and it's going to be bound to be the result of analyzing the lambda expression, the ADU lambda of n with the definition of fact. Okay? So we basically, in this one very long step that we didn't finish following through, taken this representation that we typed into the evaluator down to scheme code that we can then use scheme code every time we call it. Right? So we've taken it. We don't need to reanalyze, reparse it. Yeah, let's look at reanalyze. We don't need to reparse it every single time. Now, in the metacircular evaluator, what would happen? Well, in the metacircular evaluator, if we had this definition, and we call, I wish I were ambidextrous, we call MC eval on blob in the global environment. Actually, blob looks more like this. So we're calling it on this whole definition here in the global environment. What's going to end up happening is that we're going to have ADU fact bound to a lambda expression. We'll be bound to ADU lambda of n, ADU if which means, this is where it happens. When we call ADU fact, we are calling colored code orange code, which means that MC eval has to go through the con to parse it. And when we call that recursive fact again, we are calling orange code again, which means we have to parse it again. And when we call fact of n minus 2, because we've gone through 10, then 9, we go for 8, we're calling orange code again. On 7, we're calling orange code again. On 6, et cetera, et cetera, et cetera. We're constantly reparsing that lambda expression in the metacircular evaluator. Whereas in the analyze evaluator, we've gone through this once. We get an underlying scheme representation of it, and every time we call it, we just go straight to that scheme representation. We parse once here, we parse many.
What exactly does it mean to parse?
To basically go through that con statement and figure out what's the tag on each one.
What's the definition of parse? Not in this case, we go through con.
Okay, to basically figure out what a statement means. So if we parse English, we're trying to figure out what an English sentence means. If we're parsing scheme code, we're trying to figure out what it means. Basically taking some syntax into its meaning, the syntax to the semantics. That's effectively what we're doing through parsing. Although I should probably go for my linguist in the room to ask him if that was a good definition or not.
I think the parsing doesn't have to do with the meaning so much. Just
Right.
break it up.
Just break it up, yeah.
It's the subject, it's the predicate. The predicate is a verb, and it's object. And you can get meaningless sentence out of that are syntactically well.
Right, okay.
Colorless green ideas, sleep, furious.
Yes.
That makes perfect sense.
Yes.
So if we were not metacircular, if this, I mean, the analogous process in an actual compiler or, you know, or whatever is going on, is that it's going to compile things into the code that's like a lower level down from whatever it's receiving it and making it faster that way?
Sure. Let's go for this analogy. Basically, what you're going to see in John's presentation this afternoon is registered machines. And then as he goes on to registered machines, talks about the compilation. He'll talk a little bit about a recitation tomorrow and then more in the optional on Sunday, is that you can take scheme code and take it to register machine code. And that taking scheme code to register machine code effectively is compilation. But what you can think of here, in some sense, is that we're compiling orange code, our metacircular code, into scheme code. Now, scheme is an interpreter, so it's not really a full compilation. But we are actually figuring out the syntax of that and compiling it into, making it into something that will be simpler and easier for us to evaluate and faster.
Okay, so we're like kind of...
We're compiling between level 1. So if you think of when I, a couple days ago, wrote up, level 1 was what we type into the metacircular evaluator. Level 2 was the metacircular evaluator. Level 3 was scheme. So we're taking level 1 down to level 3. We're kind of hopping. Rather than always having to use level 2 to do our interpretation for us, we're hopping it over by doing this analysis. Yes?
Yes.
Other questions? Do you want to write some more analyze procedures? Can we just write, why don't we write analyze if? Or would you like to write something else? Let's do if. If will be fun and exciting. Yeah. Caffeine's starting to hit. Yes. And now it's time for speed lecture. Gosh, I've gotten so comfortable in front of this silly camera. At the beginning, I was like, oh, camera must be very serious. Oh, goodness. But now people all over the world will watch me being crazy in the morning.
Sorry, I didn't know we'll just slow those ones down.
Yes, these should be put up on a slice, slowing down. Oh, God. I hope it's not that bad that we need to have that sort of... At the beginning, I was like, oh, camera must be very serious. Oh, goodness. But now people all over the world will watch me being crazy in the morning.
Sorry, I didn't know we'll just slow those ones down.
Yes, these should be put up on a slice, slowing down. Oh, God. I hope it's not that bad that we need to have that sort of running commentary back there.
You just don't need the commentary to go.
Oh, I see. Yeah, okay.
Alex just lowered the
Yeah, they mean on the audience, of course. I'm assuming.
Oh, you guys want to be on camera?
Yeah, they want to be famous.
No, I thought no. What if you piss me off?
I've made Alex very angry. Don't make Alex angry. You won't like him when he's angry. Yeah, you guys are old enough. See, when I lecture a lot of the undergraduates and you do references like that, they go, Hulk, what? I wasn't alive in the 70s. Okay, before we had talked about with the analyze if, that this was the P-proc, the C-proc, and the A-proc. So P-proc, C-proc, A-proc. I therefore have done the easy part for you. What is the predicate procedure going to be? Well, we have, let's assume that we have some selectors, if predicate, if consequent, if alternative, because we do. What do we need to do when we pull out the if predicate? Analyze it. We're going to analyze the if predicate. Am I doing anything here that is telling me whether or not that predicate is true or false? No. 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 Okay. We're just analyzing it. We're just figuring out what it says. We're not doing anything until we end up applying it to environment. Similarly, C-proc would be what? If consequent. So the question is, why shouldn't we wait till we find out if it's true or false to analyze it? Well,
You could analyze the predicate because that has to be analyzed anyways.
right, but let's say in the case of fact, we're defining fact. We want everything inside the body of that factorial to be analyzed. Because if it's not, if we've only analyzed the predicate, we've left the consequent or the alternative to be done, we will need to analyze whichever one we need, the consequent or the alternative. In this case, we're analyzing two things, but if we called fact of 10, we would end up using the alternative, in this case, the way we have it written, 10 times, and the consequent once, which means that we would end up analyzing that alternative 10 times, once for every single time we called fact. Right? So you can think of it as, it might be wasted computation, but it could be a big win for us, and especially if we even call fact on a larger number. Right? Because we haven't, if we leave anything inside that hasn't been analyzed, it means that every single time we recall that lambda that we've built up, we need to go off and basically interpret that portion of it, just like we were doing in the metacircular evaluator.
Could you act like a stream and only parse on demand? So if something were never asked for, it would be left unanalyzed? Leaving promises everywhere?
Yeah, if we were to use streams, then they would be memoized, so then it would probably be okay. But I'm not going to write that evaluator for you. But we probably could write an underlying representation that was a stream somehow. Yeah, it's like lazy evaluation. It's in the book. We're not going to cover lazy evaluation, though. But basically, with lazy evaluation, you don't actually evaluate anything until you need it. Whereas we always evaluate all the sub-expressions and then apply first the rest. With lazy, you wait until you actually need things. I like lazy, okay. All right, if alternative. Did I just close my let? 1, 2, 3, 4. Okay. So here I am. If. Do I really want an if here? No, no, of course not. What do I want here? What do I need to return from any of my analyze procedures? A lambda. Then an if. So my lambda, which takes in an environment, and then my if. So, if. Why?
First of all, what level is the true question mark Boolean, because that's something we didn't really see until the last few days. The point.
Because here, this was written within the metacircular evaluator where we've actually abstracted true out to be true, the word true, the symbol true, instead of pound true. So that the p-proc being evaluated in the environment, which we're evaluating within our metacircular evaluator, is not going to return pound t, but will instead return the symbol true. So we need to use this abstraction for true question mark. Because otherwise, we could run into trouble here because we've got there's a different truth in metacircular evaluators.
So we translate the symbol true into pound t?
Basically, there's a primitive. If you look at the primitive list, you see that true is bound over to it. Actually, it's not actually in the primitive list. It's when we create the initial global environment. This is from yesterday's code, which you don't have in front of you, and neither do I. But basically, we set up the environment by binding the primitives, and then we add true and false to them. So you can go and look at that code when you get back.
So the real reason, since anything that's not false is true, the real reason is that if that is false,
It will be true.
false, it would normally evaluate as true.
Right, right. Anything not pound F is true in scheme. So we're checking to see if it's true. We could actually say false question mark if we wanted to, and then put the false thing here and then the true thing underneath it. But the real problem is that false is not false in a representation. We've created a new falsehood. Yeah, you know. So we had to check that. So if the result of applying our predicate procedure in the environment is true, what do we want to do? Evaluate the consequent with respect to environment. So we apply our consequent procedure to the environment. Otherwise, we will do our alternative procedure with respect to the environment. Thus ends analyze if.
We are not really using, we're not only not using MC-val, we're not using MC-apply anymore, we're just, okay.
There's a new apply. There's a new execute application. There's an analyze application, and there's an execute application. And those are new and exciting, and they're not apply anymore. Now, pproc will be a lambda expression that takes in an environment, and that will hopefully evaluate to something that we can check the truth value of. Right? Basically, we can, because it's either going to return the value false or something else. And if it's not false, we're going to call it true. So pproc is a lambda env which contains the analyzed code of the predicate. That's what pproc is. So that we pass it in an environment so that we know where to look up all or any of the variables, if there are any variables inside the predicate. We have to give it an environment so we can look them up. And then we go off and we either do this one or that one. Yes?